Welcome to part 3 of trying to get a SPI interface to work with the Polarfire Icicle dev kit. And so far, we haven't been too successful. The Polarfire has a microbus connector on it. I wanted to use these connectors, which was wired up in the schematic to these pins of A2, B2, E4, and E5. And so that's what it's wired to on the FPGA. Turns out that these signals are hardwired inside the FPGA to the MSS, the microprocessor subsystem. So my fabric cannot, my fabric logic, which I wrote here, which has a APB bus and the SPI signals, this cannot attach in the fabric to these pins. Uh, let's go to Libro, and see how I finally settled on that being the truth. And basically, when I ran synthesis, I got these errors related to these new SPI signals that I had added to the PDC files. So then I went and I clicked on Manage Constraints. Comes up with this table here. Click on left click on Edit. Left click on Edit with IO Editor. "23, 10, 11, 12, 13, 14, 15." All right, it's almost there. All right, and this is the IO editor. And then starts off on the port view. Click on the pin view. Double click on the pin name and double click again, and it's sorted up in order. And if you recall from here, we're looking for A2, B2, E4, and E5. So let's go back. That's from the schematic. So click back over here, and let's scroll down for A2 is here. The function is MSSIO, which is the microprocessor subsystem. It's not like a GPIO. Scroll down, so that's A2. Scroll down, we got B2, again, MSSIO. That's the function. Where's it? E4 and E5. Scroll down some more. E4 and E5, also from the MSSIO. So looking at the using the IO editor, I can see that these pins are not accessible to the fabric logic. And so I cannot use my Verilog design to connect to these pins. So we'll have to connect to other pins. And so um, the Icicle has a Raspberry Pi connector under it. And so we can get rid of this. We don't need this anymore, the microbus page. Let's go back to here. And so this is the schematic for the Icicle. It's on the web. And here is the 40-pin header, of which you can see there's some Raspberry Pi signals. These four down here seem like they're good candidates. They're all nice together, easy to get to. So let's track these these four signals, GPIO 12, 16, 20, and 21. So I'll double click on it to select 12, Control C, Control F for find, Control V, and that takes us to this page. I don't see anything. Why doesn't anything jump out at me? RPI. Let's keep searching. Let's click down some more. It's gotta be on here somewhere. So we're looking for RPA. See it was just signals, but I do not see RPI Gen 12. Why not? Why don't you highlight it for me? What? Why are you giving me a hard time? Nothing but nice to you, and so there's something where I have to figure out. Oh, look at that! Now you're being nice to me. So here's RPI 12, and it goes to D9. So let's take a look at D9 and the pin editor. Oops, did I close it? Did I really close it? No, I did. It's over here in this tab right here. Oh, there's another tab. You can't see it. Sorry. Now we got D9 right here. Call it RPI 12. And it's a GPIO, which is good, which means we can tap into it. So we got RPI 12, and let's just make let's see. And so this is D9, and how this is defined in a PDC file. And I did a quick look on this one already, but let's do it anyway. So I'm going to go back over to here, Git Bash, reopen my Git Bash, and I did a find on this guy here. And so here I'm doing a grep for RPI GPIO 12 in the constraints in the projects constraint folder, the IO subfolder for all the PDC files. I hit enter. And another thing that I did on here was I've got this dash capital A6, which means that when it finds this string, it'll print out that line and six more lines after it. And the dash I is for case insensitive. And so I hit a return. And we have found two occurrences of it. You can see it prints out six lines after, and it's saying that for both of them, the pin name is 9, which lines up. So this Libro reads this file, this PDC file, and it then assigns that pin. And this is how Libro can show this in the IO editor. Um, So we've got GPIO 12. What were the other signals that we were interested in using? So let's find this guy again. Back to the schematics. Find again. Find again. Scroll out. Find again. Find again. It's so hard. It should take me to this Raspberry Pi page. What's that highlighted? It's interesting. This page. That's interesting. I'm looking for RPI GPIO 12. It's taking me from page 13 to 14, 13 to 14, 13 to 14. Right up here is where our Raspberry Pi page is. I scroll in. It's telling me it found it, but it was taking me to page 13 and 14, but not 12. Whatever. So we've got this GPIOs. Okay, now we're also interested in 16, 20, 21. So let's go back over to here. Let's change our search to 16. Again, it's a nice, it's got a pinned in, goes to C6. And yeah, so this one goes to pin C6. If we go back to the Libro editor, let's see, C6, it's right here. Yeah, that's pin 16, RPI GPIO 16. And it's just a regular GPIO, and you could use it for also as a clock. So maybe I'll put the clock on that one. I don't think it'll matter. Would it matter? Nah, it wouldn't matter. And then let's go back to the schematic one more time. So we want 20 and 21. And let's just do this one more time. Go into this guy here. And we've got, do this find again. 20. Okay, it's C9. And 21 is C4. Back to Libro's pin assignment one more time. Oops, forgot. C9 and C4. So C4 is 21. It's a GPIO. And C9 is a GPIO as well. So those four signals are available for us to use. So now, so what we're going to do is close this guy. Go back to Libro. Go back to our MPFS Icicle kit base design, which was here. If this is not open for you, click on hierarchy and double click here. And then scroll out with a control middle scroll button. And somewhere I had connected up those Spy signals, such as this one here, should go to a peripheral block, which is, so this is a signal that we added in the previous video. And we're going to rename this. So two choices. Probably the right way to do it, which we won't do, is hop into the into this file here, edit it, and change this name to something meaningful. So we're not going to do that. We are going to just say that they've got this defined. Let's not mess with it. So we're going to go back to here. Schematic. Open up the schematic. And here we got, walk right down 12, 12, 16, 12, 16, 21, 22. We'll go back to Libro. Right click on this guy, modify. So right click on what we had defined before is MBOS spy clock. What a nice name. Left click on modify rename. Select that all, delete it, Control V, say paste. So Control V to paste in what we had selected. Say OK. So they're saying it already exists. See that error message down here? I choose something else. So in here, I haven't used it yet. But we should be able to find. So find, right? Control F, Control V. I guess port. Click on port. Zoom and center, maybe. Smart search and connect. Just really want to just search. Edit. Find. Control F. Smart search. Filter. Huh. Oh, I guess that's cool. So this signal is going as a bidirectional to the MSS block. And so what we want to do is we want to no, I'm sure I'll get the hang of it soon enough. somewhere here, left click. All right, let's click on the signal, see if we can delete it. Gosh darn it all, why don't they let me delete anything? Why don't they let me delete it? Maybe rename this guy. Maybe say top. Cancel. Left click, modify, and X on the back of it. Okay. All right. So this is not defined. So when a signal is in the schematic, it's not defined in the PDC files, such as this GPIO12X. Libro will figure out a pin to put it on, and that's what we'll let it do. All right. So we want a 12. 16, 20, 21. So what I'm doing here is I left click on 16. Right click on 16, modify, put an X on the end, which puts it onto a totally different port. Libra will figure out what pin to assign it to. Left right click, modify, X. Okay. Right click, modify, rename, X. Okay. Fine. So now we've got those guys, the pins that I want. And now we can zoom back in here. Okay, so we're going to right click, modify, rename, select everything, delete it, Control V. And so the clock will go on 12 and say, okay. All right. Next guy, the CS, modify, as a right click, on the left click, modify, select it, Control V, 16, okay, Mosey, 16, Control V, and 16, 20. And that just leaves one input MISO. So let's go over here. So I'm using the middle scroll button, hitting the control to zoom in. Click on this guy here, MISO, left click, right click, modify, rename, select it all, Control V, and this is 21. Okay, so we put them on 12, 16, 20, and 21. A quick double check of these 12, 16, 20, and 21. That's what we want. Okay. All right. I think that we can do a Control S. Let's see. Let's so here you see that little star, so it needs to be saved. I'm going to click on the generate component with a left click. Hmm. I'm going to left click on build hierarchy. And that was fast. It's done. Now I'm going to leave the design hierarchy tab. I'm going to go to the design flow tab with a left click. Oh, that's not done. It's still building hierarchy. All right, I'm going to left click on design flow. And then see where we got these fail muffins. Um, it's a little bit bigger so we can see more. Um, and so we want to run through all these steps again. And we want to eventually generate a bit stream. So we'll double click on generate bit stream. Um, okay, so it's rolling. These are error messages from the previous run. So we could ignore those. Hopefully we'll get a new set of errors or none at all. Um, and I believe it's running now. Won't see any indicator that's running. It says it's starting. It's kind of slightly grayed out, which makes you think that. Got this button here for a board. So I'm pretty sure it's running. Sometimes we get some gears spinning over here. I don't see any gears. I'd like to see some gears, but there's nothing here. It looks like the mouse pointer flickers every now and then. I'm going to assume this is running. I'm going to shut down and then we'll start back up after we get something. Shift print screen.